Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 10th class maths. We have started our topics with different concepts such as real numbers, polynomial sets and trigonometry. Today we are going to discuss a typical geometrical chapter, that is the basic of the geometry, that is a similar triangles. Right? What is a triangle? We know that a triangle is a kind of a polygon which has three sides and three angles. Then when a triangle is said to be similar and when a triangle is said to be congruent, right? That's an actual comparison between any two triangles, right? If a two triangles have same shape and same size, which means all the three sides should be same, right? Then such a triangles are said to be congruent, right? For example, let us take two triangles ABC and one more is PQR. If this triangle has three sides, right, and this also has three sides, if it tells that 2 centimeter, 3 centimeter, 5 centimeter, right, let us write in random way, right. If you see here, this has three sides 2, 3 and 5, this also has three sides 2, 3 and 5, right. Do these three sides are same? 2 is 2, 3, 3 and 5 is 5, right. Do these two triangles have all three sides are same? Yes, they have. Therefore, they are said to be congruent, right. Based on that, you would have seen different congruency things such as side angle side, side, right, and RHS. There are different kinds of congruency rules which you have you may have seen in the last classes. The next thing is similarity. When the two triangles are said to be similar, when the shape is same but the size is different, right. It does not mean that it can have any size, actually it can have, but the thing is if this size is 2 times greater than this size, for example if this is A and this is 2A, right, then if this is B, this should also be 2B, if this is C, this should be 2C, that should be the fixed rule, angles cannot change, right. Then we can define a similarity when a triangles are said to be similar is when their angles are equal. The condition for the similarity is angles must be equal, corresponding angles. For example, if I say it as the angle this P, angle A should be angle P, then angle B should be angle Q and angle C should be angle R. Is that right? Then only they are said to be similar. And the second most condition is the corresponding sides ka ratio of corresponding sides are equal, right. For example, if you see here, there are two triangles ABC, triangle ABC and triangle PQR. Let us write each and every term. What is AB here? AB is C, BC is A, CA is B, isn't it? Let us take from PQR. What is PQ? PQ is 2C, the next QR is 2A, the next RP is 2B, isn't it? Now divide AB by PQ. Check AB by PQ. What is it? Here it is C, here it is 2C. If I cancel C, I got 1 by 2. Isn't it? Similarly, BC by QR. BC by QR is equal to A by 2A. A get cancelled, I will get it as 1 by 2. Right? Similarly, CA by RP. CA by RP is equal to B by 2B. BB get cancelled, I will get 1 by 2. Isn't it? This ratio is same, right? Ratio is again division of two sides. Is this value same? Yes, it is same. Then we can tell triangle ABC is similar to triangle PQR, right? Try to remember the order. This is a similarity symbol and here the order is A, B and C. Here the order is P, Q and R. Is it clear? Hope you understood till here, right? Now tell me, Can a congruent triangle be a similar? Right, when two triangles are said to be congruent, can we call them as similar also? Obviously they have same shape, the same size. Here the size may be different or same, right, but the ratio should be same, the ratio of the sides should be same. Who knows, the ratios might be 1, right. If the ratio is 1, we can tell that both the sides are equal, isn't it, which means a congruent triangle can be said as a similar triangle. But can a similar triangle can be told as congruence, right? Can a similar triangle be congruent? No, it cannot, because the size is not, may be same or may not be same, right? Is it clear? Hope you can understand the difference between congruence and similarity, right? To understand more things about this, let us start with the basic theorem, such as we are going to study about different theorems in this chapter, that is basic proportionality theorem. The next is the ratio of the areas of the two triangles, and the next with the Pythagorean theorem and their converse theorems, okay, and the more problems regarding this discussion. Shall we start? Let's start with the basic proportionality theorem. What do this theorem states? See here, once again I want to tell you, whenever you are writing a theorem, make sure that you write its statement, its proof. The proof includes the required things, what are given, what are its construction and its diagram. Don't forget these basic things, okay. Let us start the theorem. Now see here, the first thing is, one more thing I want to tell, this is the basic proportionality theorem is also called as Thales theorem. Thales is a scientist who explained this kind of theorem. He states that in a triangle, if a line drawn parallel to one side, then it divides other two sides in a same ratio, okay. Now see here, let us consider a triangle ABC. He is telling that if there is some line is drawn parallel to this BC, let us assume this BC is a line, let us assume some line DE is drawn parallel to BC, then he is telling that it divides the other two sides, that is AB and AC, in the same ratio. Same ratio is, if I cut in the half, it should cut in the, this side also it should cut in the half, that is it should be 1/2 1/2, okay. That is, he is asking us to prove AD by DB is equal to AE by EC, the ratio must be same, okay. Now let us write, is it clear? Hope you understood what is to be written now, that is the given, don't forget to write such things. What are given here? Given a triangle ABC, is it right? A triangle ABC is given where DE is parallel to BC, right? DE is parallel to BC, is it clear? Where DE is intersecting AB and AC at D and E, isn't it, respectively. What do that mean? DE is intersecting AB and AC at D and E, which means DE is intersecting AB at D and AC at E. Is it clear? Is it clear? What is that you have to write? A triangle ABC is given in which DE is parallel to BC, okay. Now let us write what is to be proved. Write to prove. The statement is, it divides in the same ratio, that is AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. Is it right? Now the next thing is we have to construct it, a few things. construction. What is that is, whatever you want to do in that, construct two things, that is construct a perpendicular here again from here. Okay, let us name it as M N and join these both. Okay, you can remember such things very nicely, right? Now the two things is join B and C, I mean B and E and C and D, right? Then draw EN perpendicular to AB and DM perpendicular to AC. These are the two lines, DM and EN. Now let us prove it. Okay. Now see here, there are different triangles you can see there. That is, there are triangles such as ADE. Under that there are two base triangles, that is BDE and DEC. Now let us consider triangle ADE and triangle BDE. Okay, consider triangle. Let us take both the triangles, that is ADE and one more triangle is DEB, right? If you observe here, DE is the common base, that is DE is DE, is it right? And one more thing is AD and BD. Now let us take the ratio of areas of ADE and BDE. Area of triangle ADE by area of triangle BDE. Okay, is it clear? What is the area of triangle AD? What is the general formula of area of a triangle? Half into base into height. What is the base for triangle ADE? For ADE the base is AD. Let us consider this is to be my base, that is AD into height. What is the height here? Height is nothing but the perpendicular distance, that is EN. EN divided by half into, what is the base for this? Base for this is BD, and the height, if you observe, the height will be same, the perpendicular distance from there to there, here also the perpendicular distance will be the same, that is the base is BD, height is again EN, half of get cancelled, EN get cancelled, we get it as AD by BD, assume it to be equation 1, right. Similarly, let us have the second triangle, is it okay? See here, the first triangle is ADE. Here in the base trapezium we have one triangle, that is BDE, and one more triangle is DCE. Clear? Let us consider triangle ADE and this triangle, that is CDE, right. Let us again take the ratio between both the triangles, that is area of triangle ADE by area of triangle CDE. Is it okay? What is the formula of area? Half into base into height, isn't it? That is half into the base of triangle ADE. Let us see from this side, it will be AE into, what is the height? DM, isn't it? Similarly, if we consider CDE, half into the base is EC, height will be again same DM, half of get cancelled, DM get cancelled, we get it as AE by EC. This is second equation, right. If you observe here, the triangles BDE and triangle CDE, if you observe BDE and CDE are CED. Here DE is common for both the triangles, I mean DE is common if you observe, yes or no, right. DE is common, and you can think that there is a trapezium or else there is a quadrilateral, right. If you observe in that, we can see that these are the two triangles between two parallel lines, isn't it? Which means here triangle BDE and triangle CDE are in between parallel lines DE and BC. Therefore, triangle BD is always similar to triangle CDE. Is it okay? Since these both are similar, we can tell it as these both areas are also equal. Is it right? It is not similar, it is actually congruent, right? We can tell this as triangle BDE is always congruent to triangle CDE. Therefore, the areas are also equal. Therefore, we can tell that from 1 and 2, AD by BD is equal to AE by EC. Isn't it? Since these both triangles are congruent, we can tell that the area of this CD and the area of this BD is always equal. Is it right? Which means this ratio and this ratio is always equal. Therefore, AD by DB is equal to AE by EC. Is it clear? This is one of the most basic thing. Once again, let me revise everything. Here, in a triangle, if a line drawn parallel to one side, for example, let us consider this triangle. If this line is drawn parallel to one side, it clearly tells that it divides the other two sides in the same ratio, that is AD by DB equal to AE by EC. You have to remember the statement. Whenever you see such kind of questions or problems, you have to remember the statement and the formula, right? Then from here, whenever you write a theorem, you have to write these things, that is a statement given. What is given? Triangle ABC and DE is parallel to BC. Even if you do not write this kind of theory is also okay. The next thing is, what is that you have to prove is AD by DB equal to AE by EC. Yes, construction. We have joined this B and D and C and D. Then we have drawn a perpendicular EN perpendicular to AD and DM perpendicular to AC. Okay. See here the proof. Consider two triangles, that is triangle ADE and triangle BDE. Okay. From those two triangles, I have found out the ratio of triangle ADE and triangle BDE ka areas, which is half into base into height. Half into base is AD, height is EN, right? In the denominator, half into base into height. Base is BD, height is again EN. Okay. EN get cancelled, half of get cancelled, I get it as AD by DB, right? The next is consider triangle ADE and CDE. ADE and this CDE. Okay, that is half into base into height. Half into base is AE, height is DM. Okay, the same thing in the denominator, half into EC into height is again DM. Half of get cancelled, DM and DM get cancelled. Therefore, we get it as AE by EC. If we consider both the triangles in the denominator, that is BE and CD, we get it as BDE and CDE are in between parallel lines. Therefore, those are congruent and will have same area, right? From this first and two things, we can equate both the things and we can write it as AD by DB equal to AE by EC. Is it clear? From that conclusion, we can even extend the explanation such as, let us see how to do that. Now see here, if a triangle is given ABC, if this is D and E, if this is parallel to this, the condition is AD by DB is equal to AE by EC. Isn't it? Yes or no? Now let us do the reciprocal for both sides. DB by AD is equal to EC by AE. This is DB. Okay. Let us add 1 on both sides. Okay. DB by AD, let us add 1 on both sides. Let us take LCM. AD, this is DB plus AD is equal to LCM is AE, EC plus AE. Okay. If we observe, what is DB plus AD? DB plus AD, which is nothing but A to B. Is it right? That is equal to here also AE plus EC, EC plus AE, which is nothing but again AC. Right? If we again reciprocal it, this will become AD by AB is equal to AE by AC. Is it clear? What is that we have to remember from the basic proportionality theorem? That is, if a line drawn parallel to one side is given, then the two conditions are AD by DB is equal to AE by AC, that is AD by DB is equal to AE by AC, but also AD by AB is equal to AE by AC. At least this is the thing you have to remember, right? And one more thing, if they ask that if this condition is given, then you have to know that this is parallel to this, that is the converse of the BPT. Is it clear? Hope you got the basic idea of what are the two questions, right? Let us have one question of finding the similarity. Let us do that. What is the question given here? DE is parallel to BC, right? DE is parallel to BC. Then what is the condition we know? That is AD by DB is equal to AE by EC. What is AD by DB given? 3 by 5. Do we have the value of AE? We do not know. Do we have the value of EC? That also we do not have. Then what is that we have to do? Just you can correlate that. What is the value of AE and EC? That is nothing but AC. That is, if we observe here, AC is nothing but AE plus EC, right? Yes or no? What is the value of AC given? 5.6 centimeter. AE we have to find. EC we can directly apply here. That is, we can write EC as 5.6 minus AE. Can I directly substitute it here? Yes, we can. Therefore, 3 by 5 is equal to AE by 5.6 minus AE. Isn't it? Yes or no? Let us cross multiply. 3 into 5.6 minus AE is equal to 5 into AE. Let us multiply. 3 6 are 18, 3 5 are 59, 16.8 minus 3 AE is equal to 5 AE. Let us take this that side, it will become 5 AE plus 3 AE is equal to 16.8. 5 plus 3 is 8 AE is equal to 16.8. AE is 16.8 by 8, 2.1. Therefore, AE is 2.1 centimeter, right? Can you find EC also? He didn't ask, but can you find EC? Yes, we can. Here we can find EC as 5.6 minus 2.8, which is nothing but 2.8 centimeter, right? These are the basic problems from basic proportionality theorem, right? Whenever you want to solve problems on basic proportionality theorem, you have to remember three things. One thing is, if he tells that DE is parallel to BC, what are the two conditions? AD by DB equal to AE by EC and AD by AB equal to AE by AC. Once again, AD by DB is equal to AE by EC. One more thing is, AD by whole AB is equal to AE by this whole AC. Is it clear? And one more thing is, if he gives this condition, then we have to know that this DE is parallel to BC. Is it okay? Done? Hope you understood till here. Yes or no? Right? Let us have the more problems of this based on the basic proportionality theorem in the next session. Okay, that is the first exercise of our chapter. Okay, is it clear? Fine. This is for today. Let us have few more problems of basic proportionality theorem in our next session. Okay, thank you.